So this is what is revolving.
This is just a column. I haven't sketched the revolver and the
Mr. Davis, what you use cryogenic method, yes?
Yes, but even in cryogenic method, for example, in chemicalizer, I should reach the temperature minus 90 and the pressure would be about 30 bar at the top, and the temperature at the bottom would be about 40 degrees of Celsius. There should be a temperature difference from top to the bottom. So always for providing and achieving these temperature at the bottom, I will need a reboiler.
No, okay.
And this reboiler will provide the stripping gas required here. The mass transfer always happens between two different direction streams. It means here the feed is going to come downward and the reboiled gas or vapor is going to move upward. And these two different streams are going to do the mass transfer. Okay? What about the top section? At the top section, I always, sometimes it depends on the purity required. But in most of the cases, you will need a condenser here. And the liquid condensed should be pumped through the top section. And here, this will provide the downcoming stream which is going to do the mass transfer with the upcoming feed. Okay? And always I try to increase the reflux to as much as possible. But I should consider the flooding and entrainment phenomenon that we have spoken. Do you remember? We'll talk about it again at the next slides. But for a distillation column, typical distillation column, I always have this configuration. A reboiler at the bottom, a condenser and a reflux pump at the top section. And this reflux pump is going to maintain the top temperature and of course the purity. It means that if I cannot condense enough liquid here, I will not reach the desired specification or purity. Okay? And here, the bottom will maintain the down section of the distillation column temperature. You should consider that we can have different distillation columns. Sometimes I'm going to install a column to separate methane from heavier hydrocarbons. The next step is de-ethanizer, and the next de-propanizer, the next de-butanizer, the next is stabilizer. You should consider that when the distillate component is lighter, it's harder to condense it. It means the energy required for condensation of methane is much higher than ethane. And the energy required for condensation of propane is much harder than ethane. So, the fluid used here for condensation should be defined according to these components. And I should check what temperature do I require here. For the ethanizer, I will need minus 19 degrees of Celsius. For the ethanizer, I will need about 10 degrees of Celsius. So, consider that you are going to design a distillation column, okay, for the ethanizer. And you know that the top temperature required is 10 degrees of Celsius. You now know that I cannot use the air cooler to be used as condenser because in this atmospheric temperature I cannot reach 10 degrees of Celsius by using air. And in most of the cases the temperature of cooling water is about 20 or 25. Okay? So I cannot even use water. That's why here, in most of the cases for deethanizer, they are going to use a refrigerant cycle. They use propane in most of the cases to cool the top stream of the deethanizer column. And for deethanizer, you need a huge heat exchanger called cold box, because even propane cannot reach and decrease the temperature to -19. It's very hard to achieve that. And because it's very hard to achieve, it's very hard to recover all the ethane available in the feed. Okay? The temperature that I can reach here will show me the purity. And if I cannot reach the complete purity and the specification, it means some of these ethane is going to leave the column with the methane. Okay? That's why the ethane recovery efficiency is different according to the different designs. Is it clear till now?
Yeah.